All right, let's look at some improper integrals here. The first one, 17, looks like it's going to be improper because of that negative infinity on the lower end. So when I set this guy up, I'm looking for the limit as b approaches negative infinity of the integral from b to negative 4 of 3x to the negative fifth. I'm going to go ahead and write it this way because my brain easier sees that integration than 3 over x to the fifth. So when I integrate this, then I'm going to have the limit as b approaches negative infinity of 3 times x to the negative fourth divided by 4. And we're going to evaluate that from b to negative 4. Okay, that's going to be the limit as b goes to negative infinity of 3 over 4x to the fourth evaluated from b to 4. And again, my brain sees this one a little bit easier than the others. Okay, so I'm going to put where I stop in, that goes first, minus where I start, that goes second. So to wrap this guy up, all we're going to do is take 3 over 4 times negative 4 to the fourth minus 3 over 4 times b to the fourth. And what happens is this term, because b runs to infinity, this term becomes a 0. So my answer to this problem is whatever that guy turns into. And according to my calculations, he's going to turn into, there should be a negative sign in here somewhere. Let me see. This should be negative 3 to the negative fourth, which makes this guy a negative 3, which makes my answer a negative 3 over 1024. And so there you go. There's working with and dealing with an improper integral. Okay, on 18, we're going to have to set up a partial fraction decomposition. So let's just factor the bottom out real quick. And I can tell that because I have a fraction in the denominator, or in the denominator of the fraction I have a polynomial, in the top I have nothing. So use substitution in this case is not going to work. And what I'm going to do is I'm going to set up 1 over x squared minus 7x plus 10 equals, let's get a better equal sign than that, equals a over x minus 5 plus b over x minus 2. When you get a common denominator from these two fractions to combine them, you're going to multiply this side by x minus 2, and you're going to multiply the other side by x minus 5. And so what sets up here is that 1 equals a times x minus 2 plus b times x minus 5. All right, and then we're going to pick a very intentional x. We're going to let x equal 2, and we're going to let x equal 5, and that'll sort all of that stuff out. So when we solve this, then we're going to say, when we look at the 2, 1 equals b times negative 3. And all I did was put 2 in for all the x's. So b is equal to negative 1/3. When I go for the other side of that, I'm going to have, when I put 5 in, I'm going to have 1 equals 3 times a, or 1/3 equals a. So, and again, all I did was I put 5 in for all the x's and solve. Okay, we've done that. So the problem I'm working with is the problem from negative infinity to 0 of 1/3 over x minus 5 minus 1/3 over x minus 2. Okay, the 1/3s come all the way out to the front, and so now I'm working with the limit as b approaches infinity, negative infinity, of 1/3 times b to 0, 1 over x minus 5, minus 1 over x minus 2 dx. These aren't too difficult to integrate. They integrate exactly how they look, so we're going to end up with natural logs here of 1/3 times the natural log of absolute value x minus 5 minus the natural log of absolute value x minus 2. And we're going to evaluate that from b to 0, so we're going to look at this limit here as b approaches negative infinity. One of the rules that we are going to make sure that we follow along with is anytime you subtract natural logs, you're dividing the numbers inside, the top minus the bottom. And so what this ends up becoming is 1/3 times the natural log of x minus 5 over x minus 2. And again, the absolute value of that evaluated from b to 0. And again, we're looking at that whole limit process. Well, when I put zeros in for x's, all right, I'm going to end up with 1/3 times the natural log of 5 over 2, okay, minus, and then when I put negative infinity in for x's, notice that with infinity, the leading coefficients are the same, which means I'm going to approach, as we go towards infinity, a 1. And the natural log of 1 is 0, okay? And so what I'm going to end up here with on this guy is 1/3 natural log of 5 over 2 minus 0, which is 1/3 times the natural log of 5 over 2. So there's a little bit of a different situation where you had to work through a partial fraction decomposition, but again, it's not that bad. And just keep in mind, when you're dealing with infinity, some things just don't change. X minus 5 divided by x minus 2, that has a horizontal asymptote of 1. Natural log of 1 is 0. Okay, so on 19, we've got the improper integral from 1 to infinity of 5x natural log x dx, and when I see this, I automatically think integration by parts. Why do I automatically go there? Because I don't see a way for either one of these to be a u to make a u substitution. So what we're going to do is we're going to set up our integration by parts real quick before we even look at our limiting process. And I'm going to let u equal natural log x. So du is equal to 1 over x dx. And I'm going to let dv equal 5x. So v is going to be equal to 5x squared over 2. This sets us up then for our integral, which is going to be the limit as b goes to infinity of, and then the natural log x times 5x over 2. So 5/2 x squared natural log x minus the integral of 5x squared over 2 times 1 over x dx. And already my senses are tingling because of this whole natural log of x situation right here, especially when we're looking at b going to infinity. So clean up inside our integral a little bit. This guy goes away, this guy goes away, and I have just the integral of 5/2 x, okay? So what's going to happen here is I'm going to end up with 5/2 x squared natural log of x minus 5x squared over 4. And we're going to evaluate this from 1 to b. So it's where you stop minus where you start. When I do this, though, as soon as I put that b, which we're looking at that limit as b goes to infinity, as soon as that gets in to this guy right here, I go to infinity. And then this guy right here goes to infinity. So what happens is this particular problem, this one, doesn't have an integral that we can solve out. So therefore we would say it diverges. So there you go, there's 19. There we go. There's all the 3 different problems. There's 19 right there. And so that's looking at a problem where you've got an improper integral with integration by parts, but also one where we can't solve it out like we would want to.